Hello mate and welcome back to Let's Code Season 6. In the last episode we added our pathfinding algorithm, which was a bit of a steep learning curve. So in this episode we're going to ease off a little bit and start adding some more of our mundane functions. The first one I want to talk about is one that we're going to add to the game room class. And what this will do is we'll return, based on a string that we feed it, the spawn position that the player character needs to go to when it enters a room. So we'll zoom in, and as you can see here, get spawn position. This is not a property, so we don't have a property decorator on it. All we say is define get spawn position, and then it's talking about itself, i.e. the instance of the class, and then it's taking in one property called entrance. That's going to be a string. Then, because we're going to be using the math ceiling function, we need to import math, and then we're going to create an x and y variables that are currently set to a default of 0, 0, or 0 and 0. Then what we're going to do is we're going to say if the entrance value that's been entered is north, so if the player is coming in from the north, then we're going to set the x position to be the width of the array, i.e. 20 in this case, divided by 2. And we're going to use math.ceiling to round it up. We don't need to change the y function because the y function is going to remain as 0 for this. Next thing we need to do is we're going to say if the entrance is south, then we're going to set the x to halfway across the screen again, but this time the y position needs to be at the very bottom of the screen, so it's going to be the size of our get size y followed by -1, because if you remember, the index is 1 less than the length, the maximum index that is. Then if it's west or east, then we're going to set the y position to be halfway up the screen. And we're going to set the x position to be to the right hand side of the screen, i.e. get size x -1. And then if we're coming in from the west, then x can remain as 0, but y will still be halfway up the screen. And then all we do is return a tuple of x, y. So that's what that function does. We're going to annotate that as well very quickly so that we don't get out of the habit of doing it. So we're just going to say method to return the spawn position of the player character depending on what entrance they take. Import the math module, the default x and y. Check what the entrance string is and set the x and y values appropriately. And then at the very bottom here, return the x, y tuple. Happy days. Okay, so that should provide you with all of the information you need to write this function. As I said, this goes in the game room class. It can go anywhere in there. It can be at the beginning or the end. I've just kind of popped it somewhere in the middle. But we shouldn't need to come back and edit this at any point, because now we know this is going to return the values that we need it to return depending on what we feed it. Something else I did want to talk about quickly was when I created the player class, or further down the line at some point, I added a position value to our player class. And to avoid any ambiguity, I just wanted to explain what that's for. This is not the player's position within the room, because the room class will control all of that stuff. The player's position is actually relevant to where the player is on the map, so which room it's in. As you can see at the moment, I've got that set to 2,2, because that's been the default room that we've been using all the way through, because it is the room that is in our map. But you can basically set the default start position wherever you want once you create the map, and then this will obviously change when we move around. So we'll need to control this value at some point, because we need to be able to say, well, we've moved north a room, so in that case we're at 2,1, or we've moved south 2,3, or whatever. So this is going to be what changes when we change what room we're in. And This will be used extensively later on, but for now, it's just I wanted to give you an awareness of why that's there in case anybody was getting confused. In the room class, we have the matrix, so we know where the player is going to be because the player will be an object within the matrix, just like all of the other entities and stuff will be as well. The next thing that I've done in our game room class is I've added 2 new functions or methods. And what these do is return the player's position, and also they return a position of a specific object. So if we want to know what the player position is, all that happens here is that we will, as you can see, this is a property. It doesn't require any arguments to be provided because we're only looking for an instance of the player class. And we say for y, x list in enumerate the matrix. So we're going to loop through the y, the rows in the matrix, and then we're going to loop through every item within that row. And we're going to say if the item, we're going to use is instance here, is if the item that we are looking at, that we're inspecting at this particular point in the loop, is the player, or an instance of the player class in this case, then we'll return the x and y. So this will give us the position of the player, and then the function or the method below it is get object position. So we're now going to be looking for a specific reference to a specific item. This one can't be, or isn't a property, because we are looking for something with an argument. And we're just going to again loop through the list exactly the same as we did before, but this time rather than looking for an instance of a player class, we're just going to compare the item at each point in the loop with the item that we're looking for. And if the two are the same, then we'll return x and y. Now remember, the item defined is a reference to an object, and item is also a reference to an object. They have to be identical in order, they have to be referring to the same object in memory in order for this equal statement to return true. So this will only work if we actually find the exact item that we're referring to. And this is actually very useful for the class that we're going to be creating next. Yes, we're going to finally use our entity class and create something from it. So if you remember, because our entity class is an abstract class, we can use some of the bits and pieces from the original class in this new one. So this is a class called Goblin, and it inherits from the entity abstract class. And we're going to take in 2 new properties. We're going to take in name and level. And then we're going to run the constructor for our entity class, and we're going to give it the name value that we had passed through as a property in the constructor here. Then we're going to say it is alive, it can attack, it can't be used, but it can move. Okay, so true, true, false, true. Then we're going to add some other properties that we need. Now we need some AI related values. So we've got an attack priority of 5, and we've got an escape priority of 1. What this means is that when this goblin is created, its desire, currently it prioritizes attacking the player over escaping. Now these 2 values will change as things happen. So as the player attacks the goblin, its escape priority will increase. Once the goblin thinks it's needs to run away, otherwise it'll die, then this will become higher than this. The escape priority will become higher than the attack priority, and then the decision will no longer be attack the player, it will be run away, at which point we'll do something else. We'll try, the goblin will try and run away rather than trying to chase down the player. We give it some hit points. The hit points formula is very simple. It's just 90 plus level times 10. So if this is a level 1, its hit points would be 100. If it were level 2, it would be 110, and so on ad infinitum. And obviously we can increase the difficulty of fighting these goblins just by increasing the level that they are. So a level 200 would have 2090 hit points. So, you know, big hit points to chip away at. And then waypoint is the position that the goblin is going to pathfind to if it's trying to escape. Currently this is set to 0, 0, but we're going to do some magic in a minute that will change that. Then we've got our getters, hit points, escape priority, attack priority, get priority. This is a simple method that just basically returns which of the two is higher, escape or attack. This just saves me having to keep rewriting the code to compare the two, because I can just simply say, depending on what the attack priority is, we can do something. Otherwise, we just have to keep rewriting this formula. And then get waypoint just returns the waypoint value. Okay, so now we have the set waypoint method. This uses the two functions that we created in the room class a short while ago. And all we're going to do is set waypoint. Now, we should only need to do this once. We may do it every time. It doesn't really make that much difference. This is not a computationally heavy function or method, sorry. So we could do this every turn. It's because the player is going to be constantly moving. The Goblin will need to reassess where it's running away to. So yeah, it's going to run to one of the four corners of the room based on this formula. So what we're doing is we're going to just create an empty tuple that's we're going to adjust depending on where the position is. And all we're going to do is we're going to say if room get object position self. So we're going to say if I am to the right of the player, then I want my output positions X. I want to be the direction that I'm running in to be to the right hand edge of the screen. Otherwise, it's going to be to the left-hand side of the screen. X0, X will be get size X minus 1. Okay. Same logic's going to apply to the Y position. If I'm this object, the object that's doing the checking is to the bottom of the player, it's below the player on the screen, then it's going to set its output position, its running away point is going to be the bottom of the screen. If otherwise it's going to be at the top of the screen. Okay, so this is really simple logic. It's just going to run to one of the four corners of the room, depending on where the player is. Okay, that's fairly simple. And as you can see, because we've taken room in as a parameter in this class, we're just using the room.get object position and room.get player position methods to get what we need. And then all we're just going to do is return the output position, i.e. the waypoint that we've adjusted in this method. So that's really dead simple. And then we can use our pathfinding algorithm in the room class, or sorry, the pathfinding algorithm is just a standalone function to actually give us a waypoint or a path to that waypoint. That's nice and simple. So that's all I've added at the moment. We're going to do more of this in the next episode. I feel like even though this is a shorter video, we've accomplished quite a bit in this video, and I want to give you a chance to wrap your head around the code that we've already implemented, specifically the code that we've added to the game room class and also to this, so that you can see what's happening and the direction we're going in. Other than that, awesome. So I'm going to end this video here. Thanks ever so much for watching. I hope you found it useful. Let me know what you think in the comments below, and I will see you in the next one. But until then, you take damn good care of yourselves, all right? Bye-bye.